Okay, so very good. And as Ali was saying, we will start the volcanic risk scenarios workshop. This workshop started in the context of cities on volcanoes. We were supposed to do a on-site event, but due to the many changes that happened to that conference, we decided to move it online, but also make it like open to any participant that would like to participate. So before starting, we thank the support from USAID, this workshop and the work that we are presenting today, and the one that we have been doing for, let's say, volcanoes and earthquakes is sponsored by the United States Agency for International Development. And we also thank the Colombian Geological Survey because many of the material that we will present was done in collaboration with them. So this presentation is made also through two projects that we are working on. We will present more details. But before we go into the topic, we want to give a brief discussion of what we are going to see today, how the workshop will work. So today we have 3 hours of work and are divided in 2 sessions. First is like the theoretical background, and then we will have the hands-on. For the hands-on, it's better if you have installed the engine, if you have a second device, and we will do exercises, but you can also simply watch and it's perfectly fine. For the theoretical part, we will give first an introduction to the GEM Foundation and the projects that we are working on or we have worked related to volcanoes. We will also discuss about damage and losses. In general, what is the risk assessment framework that we are using, how we develop exposure and vulnerability models, either for volcanoes or for earthquakes. Then we will briefly show some applications, in particular for Ruiz Volcano, Pinatubo, and some volcanoes in Quito. And then we will move to the hands-on exercise that includes preparation of the input files, running the OpenQuake engine and generating some estimates of damage and losses for the Ruiz Volcano. And we will use QGIS to visualize those results. At the end, hopefully we will have some time to hear also more opinions about how we are using it, how can we move forward, what do you think is useful, what do you think can be improved that we can use for future development. The idea of the presentation could be very dynamic, so feel free to raise your hand or open your microphone and ask something. You can also write on the chat, and we are welcome to make any pause when it's needed. So because today we are in a relatively new audience for us, which is the volcano community, we want to introduce what is the GEM Foundation, that stands for the Global Earthquake Model Foundation. It's a non-profit organization based in Italy. We have been working on earthquakes since 2009. The foundation, the goal is to have a world more resilient to earthquakes. And to achieve that, we have been first creating a global community to share and explore information earthquake related, either hazard or risk. We also develop models. So we develop hazard models, or we collaborate in the development of models for other regions or countries. We have also data sets that are useful for hazard modeling, earthquake hazard or risk modeling. And then we also are the developers and the maintainers of the OpenQuake engine. So OpenQuake is the software for computing hazard and risk. So for the ones that most of you watched the introductory video, so we present briefly what are the OpenQuake capabilities. So let's start with that is a free software with open source code. Everything is stored in the GitHub repository of the OpenQuake engine. We have multiple reviews. It's a peer review software. Constantly there are publications, meetings, and it has been built thanks to the collaboration of hundreds of practitioners and researchers around the world. Important is to highlight that OpenQuake is a multi-purpose tool, because it combines seismic hazard and risk in the same calculator. Typically for complex phenomena such as earthquakes, volcanoes, floods, usually we have one software to model the hazard and another software to model the risk. So one of the capabilities of OpenQuake is that can join together for volcanoes, for earthquakes. We also have the capability of computing either probabilistic calculations or deterministic. That are the scenarios that we will concentrate today for those scenarios. We also support calculations at different scales, so you can concentrate in very sophisticated and detailed calculations for a single site. Could be, for example, nuclear power plants or essential facilities, but we can also use OpenQuake to estimate earthquake hazard or risk at global, at national, or at regional level. So we are very flexible. Very, very important that OpenQuake allows you to incorporate different level of uncertainties, a wide spectrum. That is a big plus. And it can be run in a single laptop, as we will do it today, or it can be run in servers or clusters when we have like bigger and demanding calculations. Finally, OpenQuake is in constant development. We are updating our features, but also our documentation, the website, everything is an evolution. And there are, for more details, you have the introduction, but also all the documentation related to OpenQuake is available online. Important to understand is OpenQuake works with different types of calculators. For us, a calculator could be for hazard, for example, if I want to do a scenario assessment, then I use the scenario calculator. I can do the classical PSHA, or what it stands for is probabilistic seismic hazard assessment. So we can have that, or we can use the event-based PSHA calculator that uses like Monte Carlo sampling in order to simulate the seismicity. And for each hazard calculator, we have an equivalent risk calculator that basically estimates damage or risk in a given location. I won't go into details to each of the calculator. That's why we have the video for the introduction to the OpenQuake. But what we want to share is we have these calculators. At GEM, we also collect models. And one of our main products as a foundation was the global earthquake model, which includes the seismic hazard map at global scale, which is the image you can see here. On the top, we see the map for the 10% probability of exceedance in 50 years of the ground shaking. So it tells you, in this case, PGA on rock at the global scale. And here we see a static image. It's just a map, but in reality, what we have are the models. So the models and the results. So you can go see hazard curves, see what is the modeling, the ruptures, the parameters of the rupture. So everything is here available at the global scale. But to reach up to this point, we worked more than 10 years in order to collect the data and work in collaboration with other teams. So in the bottom map, you see like a mosaic. And what does it mean is through different projects, collaborations, or activities, we started to collect the hazard models for different regions. So for example, not everything is made in-house. Let's say the Canadian Natural Resources of Canada share their hazard model and is developed in OpenQuake, so we can have it available here. Or USGS also has for the United States an open model, so it's there. Similarly for New Zealand, for Australia, so there are different countries that release their model is open, so we can have it here or implement it in OpenQuake. Other examples could be regional models, like the case of Europe, which is a model that was also developed using OpenQuake, so it's there. There are equivalent models, for example, in India or in Taiwan, that were developed by given authors. And what we did at GEM was translate it to be compatible with OpenQuake. And for other regions, could be Latin America, Africa, Middle East, what we do is we have some projects and we develop those models together with collaborators from different regions. And in that way, we managed to create the global seismic hazard map This was the one we are seeing is the version from 2018, and we leave there the link in case you want to explore more. But at GEM, we also are interested in the risk. What is the impact of this hazard in the population and in the built environment? So we also have the global seismic risk map. So here, the top map, what it shows is average annual losses normalized by the construction cost. So I won't go into details on that, but the idea is on the top, we are seeing the combination of the hazard, that is this bottom map, the exposure for the global. At GEM, we concentrate a lot into buildings, particularly the residential, the commercial, and the industrial building stock in the world. So we have that information for every country. And combining with vulnerability, we can produce these maps like the economic losses, average economic losses, or average, for example, annual fatalities. How many people might be dying from earthquakes in the regions? So this is one of the main achievements of GEM so far. We continue in the development because the models have to evolve. And for example, at the end of 2022, this year, this December, we will have a release of new maps. So this was a brief overview of GEM. Now we are discuss like, why are we here today? So first, we are finishing, today is officially the last day of the project, TREQ project that started in 2019. And the idea was, as its name stands for, is training and communication on earthquake risk assessment. And we have divided the project into two components. One was urban seismic hazard and risk, which we concentrated in 3 cities in Latin America. And the second part, that is why we are here for doing volcano risk assessment, is the training and capacity building. Because of the pandemic, we changed the style. We were doing workshops. Before, we were doing like on-site workshops. Regarding volcanoes, we have had one workshop in Bogota, in Colombia, and one in Bandung, in Indonesia, were done during the CRAVE project. CRAVE was a project also sponsored by USAID between 2018 and 19, and it stands for the Collaborative Risk Assessment for Volcanoes and Earthquakes. So here we will start entering into the topic. So what was the idea? You can see here the different institutions that collaborated in this project. It includes PhilBox, BGS, USGS, the Earth Observatory of Singapore, Rabaul Volcano Observatory. And the idea was to work on a unifying framework for the assessment of losses, either earthquakes or volcanoes. And keeping in mind that we should have a multi-hazard exposure modeling. Basically, the main output of the project was communicating between volcanologists, seismologists, risk modelers, to understand what are the differences that we have when we aim to estimate the risk or the impact of this phenomenon. And at the end of the workshop, if you have one more comments, if you would like to discuss more, we are very happy to hear what you would like to, your contribution. And we did some applications for Colombia and the Philippines. So that's the brief introduction. Now we will move more into the risk assessment framework. And to do that, we will discuss about damage and losses. And starting with the basic framework that is now widely used for multiple perils, the idea is to define what is risk. And here we are bringing the definition from JFDRR, where it tells us risk occurs when there is a spatial and temporal overlap of these 3 elements. So first, we have the hazard that will represent how likely it is that I have a destructive phenomena in a given location. And by phenomena, we will mention volcanoes, earthquakes, floods, pandemics, any type of hazard. Then we have exposure, that by exposure, we refer to the assets or population that have a given location, characteristic attributes and values, and that are important to the community. And finally, we have the vulnerability. And vulnerability will tell us how likely it is that these assets that are exposed to the hazard might suffer some damage or losses due to that event. And by combining these three, we assess the risk. So this is fundamental for us to understand the difference between hazard and risk. So hazard, we refer to the physical phenomena and how we measure it, how frequent it could be, while risk will be the impact of that phenomena in our population or our area of interest. And the idea was, okay, at GEM, we have the expertise for earthquakes. We work a lot with ground shaking, that also volcanoes can generate ground shaking. What can we do if we join together these two disciplines? Volcano perils that are very diverse, different kind of damage, different kind of impact, and earthquakes. So we have a software, the software is flexible, how we can transform it to make it compatible with both. So that will be the rest of the presentation, is how we do earthquakes, how can we do volcanoes in OpenQuake, or how can we use them to generate damage and losses. And to start that, we will first concentrate in earthquakes, and then we will do the equivalent for volcanoes. And let me know if you want me to explain better some topics. We will go quite general, because we know that for most of you is the first time like facing like OpenQuake type of inputs and perhaps also earthquakes. So concentrating on scenarios, which means a given earthquake for a given magnitude in a given location. How we characterize them. So first, I need to define the fault type. Where is that fault? Is it a subduction zone? Is it an active shallow zone? Is it a stable continental? What is it? So I define the fault. Then I characterize the geometry and the parameters of the fault. So I have the dip, the rake, the strike, how big can be or not. And then we need to define the rupture, because when an earthquake occurs, it's not necessarily rupturing the entire fault. It could be a piece. So based on the magnitude, where is it located? Is it in the south? Is it in the north? So here, for example, this yellow rectangle is telling us could be a small event in the upper part of the fault. Then what we need to do is to characterize the ground shaking. So our goal when we are doing hazard assessment for earthquakes is to estimate how much is the acceleration or the displacement that can cause an earthquake in a given location. And to do that, we use ground motion models, also known as GMPEs, or ground motion prediction equations. In OpenQuake, they are hard-coded. We have more than 120, 150 ground motion models. Is the largest library available in earthquake software. And what these ground motion models do is, given a characteristic of the event, we have in the horizontal axis the distance to the source, and in the vertical axis what is the intensity that I can measure. That intensity can be in terms of PGA, can be in terms of MMI, can be acceleration, displacement. It's based on the authors that developed these models. And then we will see how the ground shaking will attenuate with distance. But very important, what we want to highlight here is the associated uncertainty of this modeling. So we have some equations, they give us some models, but they are very uncertain. So the thick line, black line, tell us the mean value. This is the mean value based on multiple observations, but then we also have an uncertainty associated, and is, at least in OpenQuake, is decision of the modeler to consider the uncertainty or not, and how much it wants to consider, which equation do they want to use, do we want one or multiple, and by combining these two information, the fault, the rupture, the ground motion models, then we can have a ground motion field. So here is an example of the ground motion field, where we typically are familiar for an earthquake, which is basically the red colors indicate larger intensity, and the green and blue start decreasing the level of intensity that in our case, we are visualizing here a PGA. And here is one ground motion model that we are using. So we are first visualizing the median ground value. So we are not considering uncertainty. And as you can see, it's a very nice pattern where as I get farther from the source, here the star represents the epicenter of the earthquake, then the ground motion, the ground shaking starts to attenuate. But what happens is, depending on the authors, depending which equations you use, you might have different patterns, different shaking values. So this is an example of the same event, the same rupture, but now we see another pattern. We see it elongated along the fault, because here the authors of this model are having or taking into consideration different things. So we can see, I can have, this is proportional to the distance to the epicenter, while this one is considered the distance to the rupture. So we can have different values, and this is only the median value. But if I want to take into account uncertainties, then we won't see this beautiful, like a smooth map, but instead we will see more scattering in the values, because it might be that in some cases I get higher values. At the end, they will be always higher, closer to the rupture, but they won't be as smooth anymore. And the pattern, if we plot it like smoothly, will look like this. So it will be more up to the modeler to decide how we are going to incorporate uncertainties in our modeling process.
Okay, so I talked about the geographical attribute being super important. We need to understand what is the geographical location of the assets with respect to the damaging or the potential damaging event or source. But we also need, in order, when we're talking about risk, we need to dimension what is at risk. So we don't need simply to understand where are things located, but what is located. So we need these two attributes, which are also key, which are the occupancy and the replacement cost of the attributes. Occupancy means, what is this structure being used for? Okay, so is it a school? If, for example, I'm trying to understand which schools are at risk in a certain place due to a volcano or an earthquake, I need to understand how many schools there are, how many students are there. I need to understand the occupancy, the level of occupancy of that particular, of those assets, of that exposed portfolio. And in order to dimension economical risk as well, I need to understand what is the value of those schools. More or less to try to dimension what is at risk, what can be lost in the case of total destruction of these assets. So when we're doing modeling of exposure, we put a lot of effort into understanding how many students are in these schools and what is the cost of those schools, how much these schools costs as a direct cost building these schools. But you can even start to consider what is the cost of society if we lose the schools. In that case, you will be modeling exposure in a much in-depth way. And that's exactly what you need to do if you want to really dimension risk. So geographical attribute, super important. Occupancy and replacement costs, very important. Structural attributes, very important too. Why? When we're modeling exposure, we also put a lot of effort into understanding what are structures made of and how were they built, because that allows us to understand if they are prepared to withstand the damaging event or not. So for example, in the case of earthquakes, as an engineer myself, I try to understand whether when they build a house or build this structure, someone was following the code, someone was following the construction normative or the seismic code of the country. Why? Because structures can respond very differently depending on whether they are prepared or not for the damaging event. So the typical example that we provide for this is these two structures that you can see right here. On the left, so if you're modeling exposure in the city and you see these two structures, you're going to say, they're both made of these masonry blocks, and they are both 2 stories high. Fine. But the difference between these two is that most likely an engineer was not involved in the construction of this asset in the left, whereas here there was an engineer involved in the construction of the asset, and you can see it. The structure is more regular, it's better built, has better quality. And then I can understand which one is more prepared for an earthquake and not, and hence I can give a structured classification to this structure, and hence model better the risk when I am trying, when I will estimate losses in this asset and in this asset. What is the difference when we're talking about volcanoes? Well, for volcanoes, it's quite important, for example, if there will be ash, it's quite important to understand, then we can put more effort into understanding what is that rooftop made of? What is the structure of that rooftop? What is the slope? Is it a slope prepared for heavy material to be on the top or not? And all of this can allow us to understand or differentiate which structures will be more at risk than others. And we will see later on how all of this allows us to understand fragility and how that fragility becomes losses and risk. So again, structural attributes, very important to identify when we're modeling exposure. So exposure model, I talked about the 4 main attributes when we're modeling exposure. So I put geographical attribute, occupancy and replacement cost, and structural attributes. How do we do this? So how is an exposure model built? So this is our experience working in GEM, and this is how we usually, within our experience, our knowledge, this is how we build exposure models. You can have a building by building exposure model. So for example, what you're seeing right here on this image on the right is an exposure model made by students here in the University of Pavia, and this is the city and the city of Pavia where GEM is located. And what do the students do? They go building by building with a tool that we developed at GEM. It's called the Inventory Data Capture tool, and they go building by building, structure by structure, georeferencing photographies of these buildings and saying, okay, this is a 2-story building, it's made of masonry, it's very old, so we understand that it wasn't designed to withstand strong earthquakes or even volcanoes. When we're thinking about volcanoes, if the structures were very old, people was not maybe thinking about what's the best way to protect the structure from ashfall. So all of this comes into account, and the students are able to model building by building and create an exposure model in that way. Then they try to study what is the area of these structures, and then try to give an economic value of all of these structures given that area, and so on and so on. So basically, building by building, trying to understand those important attributes of exposure. That's when it's a city. But what happens, and Pavia is a very small city. We're talking about 70,000 inhabitants. But what if it's a big city? What we were talking about, for example, the metropolitan district of Quito, which is 3 million people. So in that case, we try to understand from databases what is exposed in the city. And from those databases, we try to grab attributes that allows us to understand what is exposed. So for what you're seeing right here in this slide is actually a 3D downtown model for the city of Zagreb that combines LiDAR information with cadastre and with cadastre information in order to model the city and the build-up environment in order to understand the height of those buildings, how many buildings we have, and in that way have a good understanding of the built environment. Let me just check with Catalina. I believe that Catalina is back. Cata, if you're back, feel free to wave here and let me know.
Hi, yes, I'm back.
Okay, very good. If you wish me to continue, I will continue, and maybe I can give you the word when you want to talk about earthquakes and all of this. Here I feel comfortable because it's earthquakes. When it's volcanoes, I will let you do the talking. But so we try to model all of this when we're doing exposure, right? So I was telling you we can go building by building. We can use city databases when we're modeling a city. And how do we do when it's a global earthquake model, when it's a global exposure model, like the one Tata was showing at the beginning? If we want to understand the amount of people living in a country, their location, the kind of structures they live in, etc. In those cases, what we try to take is higher data sets. We try to understand the population distribution, the geographical distribution of the people based on census information. We also try to understand what quality of dwellings these people is living on from census information as well, cadastral information, from any database that has this kind of information at a national scale. We build these kind of models, which are the resolution of the models is more coarse, but they allow us to understand what is at risk at a level, at a national level. So that's quite important to get and to understand. So that's how we model exposure. Now, going a little bit more into what we do at the software level, in OpenQuake, what can we model in exposure? What can OpenQuake bring or take into account in terms of exposure? So in OpenQuake, you can establish an exposure model that contains the number of assets. So you can specify how many assets are in your region of interest. You can also provide a building type for each one of those assets. So through your exposure activities or through your exposure work, you classified all those buildings, and that classification can contain the construction material, the type of system it has to resist the vertical and lateral loads. So let's say asphalt, snow, or earthquakes, wind, etc. The height of the structures, whether they have been designed following the latest norms or not, that building age that I was telling you is quite important. You can also provide the software with the average area per building type, basically saying I have a lot of these buildings and this is the average area of this type of buildings. And so with the area and with the economic value per area, you can also estimate the replacement cost of those structures. You can also have the economic value of the structures, but even subdivided in different types. So for example, what is the cost of the structure itself, those walls, those beams, that roof, but also the non-structural components, the lamps, the electromechanical system, the plumbing system, etc. That can also have a cost. And we can even include the cost of the contents, because as I was telling you at the beginning, it's not just the structure that is exposed to the damaging events, it's also the contents. And even the service it provides. So in OpenQuake, you can model the contents also as well, like put a value of the contents, and also even put a value of the service that this particular structure provides, and what we can lose if we lose the structure. And you can also tell OpenQuake there is people living in the structure. It can be a non-residential structure, but it can be a residential structure, and then you can put occupancy in that structure, and hence model be able to estimate fatalities later on if this is something that is of interest of you. Further on, OpenQuake receives all of these and also allows you to put more things. So for example, if you collected more information about the when you were modeling exposure, let's say you collected information about the socioeconomic status of the person. So let's say this is a low income family in this dwelling, in this other dwelling, a mid-income family, etc. All that information you can also build and put in your exposure model. So when we're doing the hands-on exercise, I will show you how all of this is done and how it looks in the different files. I don't know if is there any questions so far. Let me see if feel free to raise your hand, ask a question, or anything. Tata, if you want, I can give you the word now to talk about exposure modeling, volcanic risk, and all of this. So
Sure.
I'm stop sharing my screen, and I will give the screen to you.
Okay, thank you, Ali. And thanks to everyone that we had I don't know, sometimes computers don't work exactly at a time that you need them. But thank you very much, Ale. So maybe to conclude the part of the exposure, it's important for all of you maybe to take note that when you need an exposure model, we have one. You know, we have one for any location in the world, but nothing comes without but. They were initially developed thinking on earthquakes. So they have a lot of information that is valuable. Perhaps we need to tailor it a bit more for volcanoes. And that is the work that we did in collaboration with the Geological Survey of Colombia to bring that exposure model that we had initially thought for earthquakes to bring it into volcanoes. And the main challenge for volcanoes is first, we need a very good geographical resolution that perhaps depends on the period. If you are modeling like lava, pyroclastic density currents, or periods that are very specific to a given path that could be quite thin, you need very good characterization of where are the buildings located. What if you model ashfall or tetrafall, the geographical region that they affect is larger, and therefore they are more permissive regarding the location of the assets. So what we did, and also Alejandro will explain more in the hands-on how we do it, is we combine different data sets in order to first improve the geographical resolution, and second, to include important attributes. Like in the case of El Ruiz Volcano, we needed the characteristics of the roof, which are not explicitly informed. It's not that we have the information for every building about how is the roof, but at least we did some proxies and some estimations using the census information, using some surveys that the geological survey had surrounding the crater of the volcano, and we use them to assume, to infer how are the roof types in the surroundings, and therefore in the rest of the, here, if I'm not mistaken, it's like 200 or 500 kilometers diameter. So what I would like to go back and say is we have exposure. It has been developed thinking on earthquakes, but that already gives us a lot of hints for even volcanoes or for floods or for anything. So we could start from there, do some improvements, and use it for other periods. And now when we are now updating the global exposure model, we are also thinking, wait a minute, now we need to be more open with the variables that we collect, because this exposure might be useful for other periods. So it's something that we have been learning. Also, I think, Ale, we haven't talked yet about the taxonomy, right? But it's something like how we classify buildings, maybe during the hands-on, we can see what do we consider, why it's important for us, which are the variables that we collect. So by explaining that, we have now completed two of the components that are a part of the seismic risk assessment. And then we will go to the last one, and that is vulnerability. And here we want to start by referencing to earthquakes. So in OpenQuake right now, we have a differentiation between fragility and vulnerability. So by seismic fragility, we represent the probability that an element that is exposed to the seismic hazard will suffer damage due to the ground shaking. And for vulnerability, instead of representing damage, in this case will be what are the losses due to that ground shaking. Important to have in mind, we differentiate fragility is related to damage, while vulnerability is related to losses. And that will be also applicable for other periods, like we will see later, and it's important to keep that differentiation. And we will see why. So first, let's think about the fragility, and in this case is due to the ground shaking. So here applies either ground shaking due to volcanic activity or ground shaking due to earthquakes caused by faults. So the damage state, basically, what we do is to classify what is like the level that the structure, we are saying buildings, but it could be the bridge or the pipeline or the aqueduct, anything. What is that state in which it will end after the hazard phenomenon occurs? So if I have no damage, I could have a slight damage, extensive, collapse. And these type of levels of damage are user dependent. I could have 1 or I could have 5. Generally, we use AdGem at the fragility and vulnerability fragility functions that we develop. We use this for damage states. And the idea is, as the hazard intensity is increasing, as I feel larger accelerations, then the buildings will suffer larger damage. And this is very important to characterize the damage, because later, based on that damage, I can have some consequences or some impact on the buildings and the population. So, for example, it would be very different to estimate how many people, let's say, is displaced after a ground shaking event, if I have a house that ends in collapse or if I have a slight damage. Perhaps this one could be repaired, while in the other one, hopefully we will have to go and check how is the status of the population that was living in the house. And about technical details, in OpenQuake, the fragility model explicitly accounts for the probability of exceeding a set of damage states. Again, this could be 4 or could be 5. And this gives the probability of being in the damage state given an intensity measure that in most of the cases is PGA or spectral acceleration, and we can have different intensities. And we can represent that in OpenQuake in a continuous way, which means a log normal distribution where I assign mean and standard deviation, or I can have a discrete function in which I assign points with given values of intensity versus probability, which these functions are generally derived from empirical observations. So if an event already happened, I can go and evaluate what is the damage in the structures, and I feed a function that gets closer to the observed information. And developing these functions is a challenging task. So there are functions for different types of buildings at different locations. So wooden buildings in New Zealand will perform differently than wooden buildings, let's say in California or in Italy. So what we have done at the GEM Foundation is that we did a collection of vulnerability and fragility models around the globe. Right now, the vulnerability has more than 500 models, but they change in author, damage states, characteristics of the building. And in addition to that, we have our global models that are used in the global model. And we try to think how to relate this with volcanoes, right? So for ground shaking, it could be exactly the same. But if I have other periods, how that will be? And that were the discussions we were having with the different groups. So here as an example, we have a table from a paper by Jenkins et al. In 2014, in which they made some reference regarding the hazard parameter and the type of damage and the cause of damage that different volcanic perils can have. And this is super, super important because this is a huge topic for all of you. How do I characterize the hazard for a given peril? Which is the unit that I need to use? Is it the, for example, and today we will work with ashfall and basically like roof damage. So we are using the load of the based on the ash thickness, but that can change based on the vulnerability or the fragility that you have. And different perils are modeled in a different way, but so far, as part of the CRAVE initiative, we only define 4 perils to work in OpenQuake. And those perils were established after a lot of communication. Alejandro already presented that. But here we want to make sure we understand why we decided this. So first, we did a surveys across the organizations that were participating in the project. And they say, you know, these are the most common like perils that we face. Also, we indicate one software that is common to be used with, but OpenQuake is not limited to the software. It's the tool that we will use today in the hands-on that is limited to the software. Like if you model your ashfall in Ash 3D, we can use directly the outputs from Ash 3D. But if you model it with another hazard software, then what you need to do is follow a set of format that is plain files to use it in OpenQuake. So you can model it by your own software or Ash 3D files. Same for the other perils. And during the discussion, we also decided which intensity and how we are going to assess the impact of these 4 perils. And here you will see that lava flow, pyroclastic density currents, and lahars were assumed as binary periods. What do we mean by binary? There are only two options, 1 or 0. One is the infrastructure population that we have at the location of that hazard peril is affected or not affected. And this is already a big discussion, because with many volcanologists, they were telling us, wait a minute, but how do you define where is the exact location that the lava flow will affect or not a building? Or how do I define that is at what distance I will consider it affected? So that is a discussion that we can keep on, like we are happy to listen other opinions from all of you at the end of the workshop. But right now in OpenQuake is just assuming if I have a given geometry, if my building is inside that geometry or at a given distance that I can specify, then it's affected. If not, it's not affected. So we only have two options. On the other hand, for ashfall, we do have an intensity, and that intensity is the ash thickness or load. So I can define the load of the ash based on the volcano footprint that I'm estimating, and then I can have like a continuous field. In that case will be the ashfall, and I can use fragility and vulnerability functions to estimate damage and risk. So as an example, we brought here the fragility that we use for Ruiz, which are the functions proposed by Torres Corredor, 2017, that were developed for Galeras Volcano. It's very, very important to highlight that, as opposite for earthquakes, for volcanoes was much harder to find such functions, because still we are using other methodologies to assess the risk. But in that broad concept, what we would like to understand is, okay, to characterize the impact of ashfall into my buildings, what I need to identify is the type of roof. So in this case, the authors did a study regarding how are the houses and the roofs of the zone surrounding the Galeras volcano. And they define, it could be a light roof, it could be a moderate roof, heavy roof of a concrete slab or a flat slab. And based on that, they derive the fragility functions. So here on the left, we see the example that I have different type of roofs, but check, there is only one damage state. So it's not that the roof is slightly damaged, moderate damage, or collapse. No, here is damage or how likely it is that will be damaged given the ash load. That means that we have two damage states, no damage or damaged. And of course, as the load of ash starts increasing, it's more likely that the roof will be damaged. Who defines those level of damage or different damage states are the authors of these models, the ones that have to decide. Here we have another example by Spence et al. For roofs in Europe. So there are different types of roofs, if it's weak, if it's made of wood, if it's strong, and then we have different levels of damage. It's, again, so only referencing here collapse. No, it's not anymore damage, it's collapse. So during the hands-on part, we will give you a spreadsheet in which we collected like 5 or 6 models that are available for ash. But if you have more, we are very, very happy to hear like which other models there are, if there are for other periods, to see how we can incorporate it. Because in OpenQuake, the concept is the same. We include uncertainty in the modeling of the vulnerability. So I can have continuous, discrete, I can even add more dispersion into these functions. And we can model the impact on the roofs for ashfall or tetrafall. And in addition to the damage, then we can also use consequence models to estimate the impact. And a consequence model here refers, also it's known as damage to loss model, that establish the relation between the physical damage, means, slide or collapse or moderate damage, with a corresponding loss ratio. So the loss ratio here could be how much are the economic losses. So if I have a collapsed roof, I will have a given consequence for economic losses. Or if I have a collapsed roof, I will have a consequence model for, let's say, fatalities, how many people could die of the roof collapse. So it will be different if I have a weak roof or if I have a heavy roof. And we will also explore that in the hands-on. In OpenQuake, we can have deterministic consequence model. It means I give a value. If the roof collapses, then 100% has to be repaired. I can put 1, or I can put, no, I have to remove the debris and then repair the roof. So it could be 1.2, let's say, the ratio. Or I can have a probabilistic model in which I don't indicate exactly a value, but I give a mean and a standard deviation. And I can give a probabilistic distribution, which can be beta or log normal, in which I say, look, if I have a damaged roof, then the economic loss could be between this value with this uncertainty. And that can be modeled in OpenQuake. That's what we call consequence models. The other option is, instead of using first fragility, then consequence, I can go directly to vulnerability. And in this case, vulnerability tells me directly what is the probability of loss for a set of intensity measures. So I could say for this load of ash, then I have a given ratio of economic losses or fatalities or displaced population, injuries, different type of consequences. I would like to know if up to here things are clear. If you have any question. Here, Carlos Laverde, who also works a lot with us, is sharing a book.
Is the methodology for evaluating the vulnerability and risk due to the follow material that has pyroclastic material that is transported by wind?
Thank you very much, Carlos, and please feel free to talk. Carlos was was very involved in the work that we are presenting today, especially in the hands-on and the discussions. So with this, we have completed the 3 components of the risk framework. And we are now going to summarize what do we need and how do we do it in OpenQuake. So first, the scenario damage calculator, that is the name, is important to have the name as a reference, because when you run OpenQuake, you need to have to decide which calculator you are going to use. And something good after this workshop, I should know if I want to run damage, then I used to use the damage calculator. We uses fragility functions. So what I will need is the ground motion fields in the case of ground shaking, and I can use the median value, or I can use multiple simulations of the ground motion field that account for the uncertainty of the phenomena into OpenQuake. Then I need the exposure model. The exposure model needs to follow a given format. You will open it, explore, and you will prepare also an OpenQuake exposure file. And then we need the fragility functions. Of course, all of them have to be compatible. For example, the ground shaking has to be at the location of your assets, and the fragility functions need to be defined for the building classes that you have in your exposure. Then OpenQuake combines all these 3 input files, and it can generate damage distributions or damage maps. So by damage distribution, I can, for example, understand how many buildings of type 3 have collapsed. So could be how many buildings with weak roofs have collapsed, how many buildings with strong roofs have collapsed. Or I can compute maps. So here is an example of a damage map due to an earthquake, where the star represents the epicenter, and as darker is the color, I will have a different, a larger number of buildings in each damage state, because here we are seeing different damage states: slide, moderate, extensive, and collapse. So this is one type of output when I have multiple damage states. But if in addition to the fragility, I have a consequence model, then we can also estimate loss statistics. So by these loss statistics, they can be economic losses, affected population, number of fatalities, and we can also have maps for each consequence. And this will be the calculator we will use today in the hands-on. But this is for ground shaking. Today we will use for volcano, and we will start from the hazard footprints. In this case, I have the ashfall, I have the exposure, I have the fragility, the consequence, I combine, and I produce different impact in my exposure model. Here, it's very important to highlight that this volcanic hazard footprint could or could not include uncertainty. And we as the risk modelers need to have that in mind. Generally, the hazard footprints represent the maximum envelope. If they are representing the maximum envelope, it means that I will have an overestimation of my impact. But instead of having one, I could model hundreds, thousands of hazard footprints from the same eruption to have some uncertainty, some variability in my model, and then I could have some statistics about it. We will, at the end, present a brief application, but it's important to say that it's up to the modeler what we input in the software. If we input the maximum envelope, we will overestimate. If we input the median, we will underestimate because we are not considering some extreme cases. So OpenQuake has the capability to model multiple hazard footprints, but it's up to the modeler to decide how many they are going to model. For example, in earthquakes, we usually do 2,000, 1,000 simulations for a given scenario. So it is up to the modeler. And here is an example of what is our goal, that today in your own computers, you install OpenQuake, you install the QGIS plugin, then you will be able to visualize and generate these maps for the binary perils, which are lahars, pyroclastic density curves, and lava, and different simulations for the ashfall. This will be the second part that we will start soon. Then during the TREQ project, we say, okay, now we have that capability in OpenQuake. Can we actually generate volcanic scenarios for other regions? And in TREQ, we work in 3 cities I already mentioned: Quito, Cali, and Santiago de los Caballeros. So the municipality of Quito asked us, wait, now we have developed a very detailed exposure model. It's a building by building model. It has information about roof type, heights, construction materials, a lot of information. So they were asking us, can we apply that for the volcanoes that we have in the city, given that we have the hazard footprints? So this is the result of those simulations. So we did volcanic scenario profiles. In this case, the scenario profiles were built in collaboration with the city stakeholders. They were telling us what they would like to see, how it could be useful. So these volcanoes, these profiles here on the left have the map. On black, you can see the hazard peril, some description, and we did them from 3 volcanoes in the city: the Atacazo, Huahuapichincha, and Cotopaxi. We write largely our preliminary results, because when the collaborators were seeing these outputs, they were saying, oh, but this is very, very like a strong impact, because we are assuming the maximum envelope for each event. So the results are very, very pessimistic, let's say. But here we only use one hazard footprint. We are still missing all the possible simulations. And that is like what we have right now, but it could be in the future. So if you are working in Ecuador, specifically in Quito, now you have an open model. Here we leave the link that you can use for your applications, and you can use OpenQuake and generate some risk estimates for the different periods that you are working on. And the last application we wanted to share was for the Pinatubo Volcano in the Philippines. So we worked together with the group from EOS, led by Susanna Jenkins, and they facilitated the hazard footprints for tephra fault from a probabilistic scenario modeling. So in this case, what we have are they have different seasons, so different wind directions, different heights of the column of ashes. We have the different wind roses that have different alternatives in the modeling. But at the end, what we got was 5,000 footprints from 3 simulations. One that considers the whole year, one for the rainy season, and one for the dry season. And those change the direction of the wind. So what we have in total are 15 simulations. And what we can do is to estimate not anymore an absolute value for the impact, but instead we have a mean and a standard deviation at each location. So here you can see the mean economic losses or the mean number of collapsed roofs due to tephra fall in the Philippines. On the left, you see the consequences for the dry season, for the rainy season, and considering all seasons. So here, instead of concentrating in the maximum envelope, we are considering different alternatives, which also led us to lower values than if we use the entire envelope. And this is a very, very important difference when we are looking for hazard footprints from different volcano periods, because the most frequent way to find them is the maximum envelope for the given volcano. So it's good for us if you share experience that you are modeling also in a probabilistic way other type of perils, or if you have different vulnerabilities that account for different characteristics in your hazard footprints. So we can think how the OpenQuake engine will need to get transformed in the future in order to be able to support risk modeling for earthquakes and volcanoes, and hopefully in the future for other periods. If you have any questions so far, we would like to know, because I believe this is the last slide that we wanted to share. There are some useful links. The slides of these presentations are available on the OpenQuake training website, so you can go and download it as well. Yes, we have a question from Lucia. You are muted. Could you please unmute?
Yeah, sorry. Thank you very much for your presentation. It's super interesting, super clear. I have a couple of questions. One is concerning the exposure. When you define all the different models for, it's more regarding regional and global maps. When you choose the different models per country, I guess, how do you define or how can you do comparable data sets? Because I guess you have a data set for a given country, and then, for example, here you are showing US and then Mexico and all Central America and so on. So I guess you have different level of resolution and completeness of each data set. So how do you do to match all these?
That's an excellent question, Lucia. Thank you. So first of all, we do not match. What we do is that we work at country level. So for every country in the model, I believe we have 220 countries. We go and we look for the information at the smallest possible resolution. So I will give you an example. If you go to the US, the HASUS model is open, and it's available at Census Track of the US. So it's a very, very fine resolution, and they give you given attributes that we translate into the GEM taxonomy, which is the identifier to classify the buildings. But what we look always for is to find these building characteristics: material, lateral load resisting system, that it means, do I have columns or do I have walls? Do I have, for example, posts and beams in informal wooden houses or metal sheets? What is the height of the building? Because at least for earthquakes, that is fundamental. And what is the ductility level that Ariane mentioned? Is it compliant with the building code? Is it following the requirements that the code or the recommendations that the code is saying for construction? Which already those help for anything, because even if I know that my building is following the code, depending in which region we are, for example, if there is snow, they might require to have a pitch of the roof. So that will also affect for ash. Or if I'm in a country in which asphalt is considered as a load in the building code, I know my buildings in that region should follow some design provisions. But sometimes it's not the case, and we also report they are informal. So we try to report that per country. But as you can imagine, not all the countries have that information. So here we have exactly the example for Haiti, in which for us was impossible to access census data. For instance, we got our first source of data is the census, because census tells you occupants, households, dwellings, and material of the buildings. Almost all census in the world give you that information. But in Haiti, unfortunately, we couldn't manage to access the census data. So what we had to do was to go for population distribution, nighttime lights, and from there do proxies. This is what is called like the bottom-up. We did a bottom-up approach, where here is an upper to bottom approach. Okay, so here, yes, I know where is the population, but we don't know how many buildings, we don't know where are they located exactly, we know where is the population, so we do some values. But if you go to our models, we do differentiate that information in the exposure, and you can find, okay, this one is made from satellite imagery, like it's an approximation. It looks very nice, it looks like distributed along the country, but it's not that it's at that level. While in other countries, for example, Mexico, all the Andean countries, at least Venezuela, Colombia, Ecuador, all of them had, the eastern part of South America is modeled more approximately because they have less earthquakes. So the approach was less detailed there, since in that case, we didn't concentrate too much in non-earthquake prone areas. But then it changes. We don't homogenize the data. Each country has their own building classes, but at the global level, they are compatible in the sense that we use the same classification system. I hope that answers the question.
Yeah, I mean, yeah, it's a big challenge. I mean, for earthquakes, it's more localized anyway. I mean, obviously you can have some earthquakes in a border, for example, where you will have the impact in the two countries, and then you will have a problem. Mm-hmm. Of course, if the two countries are not in the same level, in the same resolution for the exposure. Mm-hmm. But in volcanoes, you will find that much more, particularly, for example, I don't know, some countries like Chile, Argentina, or some countries that you have the largest hazard, like a tephra fallout, then you will have a bigger problem, let's say, trying to combine the level of exposure on both countries.
Well, I will tell you, the main challenge here is not the exposure itself, it's the vulnerability. Because in the exposure,
yeah, exactly, yes, you're right.
Different resolutions, but at the vulnerability case, you will have to say, I need something to compare. For example, you need to use the same damage state. It cannot be that some functions for a given country will tell me moderate and collapsed roofs, for example, and the other one will only tell me damaged roofs. No, and even OpenQuake doesn't allow you to do that. So it's our task as risk modelers to go and say, okay, which functions are we going to use? How I'm going to apply them to different building types? And then I will have like uniform outputs. Could be at different geographical resolutions, but also we will see in the hands-on that OpenQuake needs a latitude and a longitude. So even if I have a bigger region, I need a latitude and a longitude to define what is the hazard intensity at that location. So I think once we do the hands-on, you will think, okay, how do I combine different regions? How I do it could be more clear. Okay, very good. We have also
Luis Misco has. I don't know if Lucia had another question also. I don't know if it was only about exposure.
No, I have another one, but I will leave the others.
Okay.
Yeah, maybe later. Yeah.
Yeah, of course, we can answer later on, no problem whatsoever. Luis,
hello, good morning here in Central America. Well, thanks for your excellent presentation and all of these features that OpenQuake offer in order to assess these natural hazards. I don't understand so deeply about the treatment of the uncertainty, especially when you explain the inputs related to the volcanic hazard footprints. Because I don't know if in the workflow of using this scenario calculator, we can use some kind of logic tree in order to consider these uncertainties and also to use these maximum envelopes and also this median as well. So I don't know if it's possible to do that in this case.
Thank you, Luis. I think it's a very, very tricky question. So OpenQuake right now as it is not providing a logic tree for the multiple hazard footprints. But because OpenQuake can be run with command line, which means from the terminal, it's very easy to do that batch calculation, which means you can run 1,000 calculations with a code, and it's very fast. Okay, so you could do that from outside right now. And we are saying right now because we need to hear more the feedback for risk assessment with OpenQuake using other periods. Because for earthquakes, we can use it because we are calculating the footprints directly in OpenQuake. But when we import the footprints from other periods, then we are the ones that we have to arrange it in a given way. Right now, we could experiment arranging it. If you have multiple, we are happy to discuss more after the workshop because it's possible. It's just that right now, how it's written OpenQuake, it seems that it's for earthquakes, but it's applicable to any set of lat, long, hazard value.
Very specific.
As many simulations you have, and it's possible to do it.
Okay, I understand. Thanks, Katarina.
You're welcome.
you're welcome.
So here we also see a question in the chat from Risky. It says, maybe this question to brainstorm in our mind. If you do want to answer, you can put more in the email. She's a working master student in Taiwan. Say the volcano in the center of ocean and high activity named Krakatoa. If we have the good data in the vicinity region there, it's still we can calculate volcanoes risk assessment there. Okay, thank you, Risky. So you can estimate volcanic risk anywhere if we have the information. I will have to check if we have that for Indonesia, which I think we have. Actually, currently we are doing a project in Indonesia. As I think it's Lucia was mentioning, for volcanoes we need to see the resolution. So could be that in that island, we don't have a very good resolution. So you will have to use additional data sets to improve your resolution in order to evaluate the risk. And also for volcanoes, it's very dependent on the period that you are assigning. Are you going to do ashfall or are you going to do lava flow? That would change completely the needs of your exposure. And I think after we do the hands-on and you will see and visualize the exposure model for the vicinity of the Ruiz volcano, then maybe we can talk more once you get more familiar with that type of outputs. You start thinking, how can I use the software, the data that is available? How can I ask for? So we will see that, I think, later on. I don't know if there are more questions.
Lucia has a question.
Lucia, please go.
Yeah, it's given that the other, yeah, don't have. It was related to the consequence models. Just it was a doubt when you explained the fragility curves. That's clear.
Catalina is
I have an echo.
You have the same issue. Can you mute your microphone, Catalina? I think we will keep hearing it, but if you ask me
I'm
the
not
question,
sure if it's from me because I'm not experiencing this.
let me see. In any ways, Lucia, you can ask, and we will try.
Okay. Okay, it was related to the consequence model. You said, I mean, you explained all the fragility curves related to earthquakes, both on tephra fallout.
Mm-hmm.
But then for the consequence model, you are using the same of earthquakes. I'm correct? Or you are using specific consequence models for ash?
No, in this case, well, Kata, you can ask, you can answer. Let's see, let's test.
Yeah. So let's say two things. In OpenQuake, is the modeler the one that defines the consequence model? Is the modeler that defines the fragility? And I'm just saying it because it's quite a common question, thinking, OpenQuake will have some fragility included or some consequence. So it's me as a modeler user of the engine that I have to define. Can you hear me? Because I still hear that noise.
We hear you, but it's strange to define the noise because everyone's muted. So. Okay,
so for El Ruiz in particular, we use a consequence that we define together with the geological survey because we don't have a specific consequence. Okay, and we use affected population that was mainly like where the peril, any peril, touches the house, then population will be affected. And we use the economic losses based on the damage that is generated in the buildings, in the roofs. So we decide from the cost of the building, how much is the cost of the roof. Most of the time, it won't be a complete collapse of the building itself, but only the roofs. And then we were doing some estimates based on that. But we haven't explored deeply how are the consequence modeling for ashfall in this case. For ground shaking, and I think we already mentioned it at the beginning of the presentation, we have around 9 ground motion models or GMPs already implemented for ground shaking due to volcanoes in OpenQuake. So if it's due to ground shaking, we can use the ones that we have been investigating for. If it's for ash, it's more like up to the modeler what decisions will take for that case. Okay, very good. So I think now this was the last part of the theoretical background. The idea that we wanted to share with you is, first, we need to understand the phenomenon. What are we going to calculate? So now you are familiar what is an exposure model, what is vulnerability, that we are only start from volcano footprints to estimate the risk, and then we will move to the hands-on. And before we make the break, let me share with you, can you see now the OpenQuake website? Yes. So we invite you first to grab a second device to do the hands-on exercise, because it will follow. It's easier if you have a second screen, your phone, your tablet, anything. If you don't have, then not a problem. Come to the Volcanic Risk Scenarios tab and download the material here that is available in the website. I will say it again. Come to the Volcano Scenarios tab and download the material that is here. It will direct you to a drive. It's a zip file that you need to download. If you had any issue installing the software or doing anything with the tools that we ask you to install, please let us know now during the break. We will have 5 minutes break. And we will come back here in 5 minutes. I don't know, Ale, if we need to do something else before going to the break.
No, I think that will be okay. So in 5 minutes, we will be connecting again. So see you everyone very soon.
Okay, so see you in 5 minutes. That means 44.
Okay. So thank you very much. Thank you very much, Tato, for the explanation of the theoretical background. If I'm not mistaken, you're finished with this slide. We have a final slide. So what we want you to do right now is you downloaded the material for the exercise, right? So it's a zip file actually. The first thing you need to do is unzip the file and place it in somewhere in your computer where you have a good access to it. So what else do you need? You need to have installed the OpenQuake engine, and you also need to have a QGIS stable version installed. Very good. So let me go back so you can see what is the example for today. So for the example for today, this is a hands-on example that we prepared using all the files that we have for El Ruiz Volcano. So for El Ruiz Volcano, we have a certain hazard footprints. We also have an exposure model, and we also have fragility and vulnerability. So the point of the exercise is to walk you through how does it work in OpenQuake? How do we prepare the files? How do we put them in the engine? How do we run the calculation? And last but not least, how do we plot and how do we see these the risk and the outputs in a QGIS or in a GIS platform in a way that it's that is nice to visualize, right? So what we are going to do is just to locate you geographically where we are. We are actually here in South America, in the country of Colombia. And again, what we have is volcano footprints that were shared with us by the SGC, or the Servicio Geológico Colombiano. And we have footprints for an ashfall. We have footprints for lahars. We have footprints for lava flow, and we have footprints for PDCs. So the idea today is that we're going to be calculating losses, damage, and given this hazard footprints. Again, remember that in the case of ashfall, we have intensity that is discrete, right? It's an intensity that basically it refers to the ash thickness and the load. Whereas for the lava flow, the PDCs and the lahars, what we have is a binary file, right? So what we're going to do right now during the exercise is to see how we define those things in the OpenQuake engine. And we are also going to explore the exposure model. So let's start with the exposure model and let's talk a little bit about that. So the exposure model today was developed using census administrative information. So what we have is how many people live in these areas and in what kind of dwellings do they live in. And hence we developed an exposure model based on that. So the exposure model was developed at a census level, and then it was disaggregated in order to have the appropriate resolution to do these kinds of analysis. How do we disaggregate it? We take into account population grid, we take into account water bodies, we take into account additional data sets like roads, water bodies, etc. And so we come up from a model, as we were discussing before, from a model that was created just having a single point per administrative area, because that's at the level that we have the resolution, to have a model that is more dispersed or more, it has the appropriate resolution that we need to do these kinds of analysis. Again, this is what we're doing today is an academic scenario, it's an academic exercise. It's just to exemplify to you how the process is and how you can apply it in your own research or investigations if you're interested. So first things first, let's see that exposure model. Let's open that exposure model. In the beginning, when I was explaining about exposure, I I talked about these main attributes that we need to model exposure and all of that. So let's see how that looks like in the actual database. So I am going to exit the presentation and I will go to the material of today's exercise. For me, it's in my desktop. So I will just double click on that folder, which is already unzipped in my case. And what we're going to do is double click on the exposure folder. And the exposure folder has a Ruiz exposure complete.xlx. This is the file, the Excel file is the file that we can open and explore. The other ones are the ones that OpenQuake will need, and I will show you how we input this in OpenQuake. But the XLS, the Excel file that we are providing you here, and you can double click on it and start opening. It's a big file actually. That is the file that we can open and explore. So how does it look like? Here in this Excel file, we are using some color coding to explain some basic things. So remember that I was telling you an attribute, a geographical attribute is necessary when we're modeling exposure. Well, in the exposure, we have two columns. In the exposure file, we have two columns that give you the longitude and the latitude of the particular assets that you have in the database. So basically, it's a georeference data. So every row in this file is one exposed asset. One exposed asset can be a single building, right? Or it can be a group of buildings. How can we group the same group of buildings in the same point? They cannot be one on top of the other. Well, depending on the resolution that you're having, you're going to have to do that. Sometimes even in a single lot, in a single property from a single owner, he can have his house, he can have a shed for tools, he can have maybe a warehouse. So you can have more than one building in a single location, even in a very high resolution model. So this is why we use for each row, it's one asset, and each asset can have more than one building in it. The column that tells you how many buildings are in this particular location is the column called number, okay? And here we provided some tips for you to read and see, oh, when I'm modeling exposure, then the number means the number of attributes that belong to this typology and that are in this location. The other important, so I said we need geographical attributes. We need to understand how many people and how many, so occupancy and replacement cost, right? So occupancy and replacement cost, we already know that number is the number of buildings that are there. So how many buildings are in this location? And occupancy will be night. Night means how many people are we modeling inside this location during the night, meaning that we are considering that people is mostly on the residences and not outside, okay? This is important for earthquakes, for example, because when an earthquake is occurring, the level of loss that you see in terms of fatalities is very different if the event is occurring at night or during the day when people is transitioning or outside or on a weekend when students are not in schools, things like this. So basically the word night symbolizes what kind of occupancy we're simulating here. And here we can see that most assets in this case were modeled having four inhabitants in there. So location or geographical attribute with the longitude and latitude. Then we said occupancy and economic value. So we also said replacement cost is absolutely necessary when we're modeling exposure. Here, what you're seeing here is the economic value of this structure or the structures that are in this particular location in US dollars. So the whole value of this structure, the structure that is here, or this single building that is here, is $36,000 US dollars. Right now, what we have here is the cost of the structures. So we do not have those additional columns to have contents, to have non-structural elements. All of those we are not considering today. Today we're doing an analysis only for these structures. But remember that those we can have when we're doing the analysis or the assessment. And structural attributes, a structural characterization, we thought that is very important when we're modeling exposure, and it is right here. Tata was showing us that when we're talking about ashfall, which is the discrete intensity that we will be using today, is that hazard footprint that has different intensities. We need to understand basically the quality of the roof and the cover of this particular structure. And we classified, you will see that in this entire exposure model, it is classified in those 4 types that we saw before. So for example, in this particular longitude and latitude, we have one building with this economic value, and this one was classified into weak roof, okay? So the taxonomy is that particular code that describes the structural typology. So this is how you, if you were wondering like how does exposure model looks like, this is how it looks like. In pink is what you really need, what you most necessarily need in order to do or do an appropriate risk assessment. The ID refers to a specific identification for each of the assets, because later on you can ask a risk per asset. You can visualize the risk per each asset. So each one needs to have a specific name. There can be no duplicates in the IDs. That's all what the ID column does. So that's the basics of exposure, right? But I was telling you that we can also use additional information when we're doing modeling exposure. For example, in this case, as additional information, we kept the earthquake typology as well. So in terms of volcanic risk, this is a structure with a weak roof, but in terms of earthquake risk and fragility, earthquake fragility and vulnerability, this is an unreinforced masonry structure with 1 story. And again, if you are wondering what is this strange code that is being used here, this is the GEM building taxonomy. This is the way we use to generate or describe very fast using a simple set of codes. What is the whole description of this building? So this is how it looks. The exposure model. We have additional tags. For example, we have a tag for the census ID, so I can later on visualize risk not by a type of roof, but also by census ID, so I can understand a risk per census tract. Or I also have a tag for departments and municipalities. So basically, I have different levels of administrative regions, which allows me to visualize risk later on in terms of departments or municipalities. So what you see in blue are tags or additional information that the exposure modeler gathered and kept in the exposure model, and OpenQuake is able to use this information too. In pink, what you see is what is most necessary, what you really need. Without these things, you cannot evaluate risk, right? So I hope this is clear. This is how it looks. If you have any questions regarding this, please raise your hand and tell me, can you explain a little bit more about how this is done? But basically, this is, we can see how many rows we have in this file. You can see there is a lot of rows in this file, so there's a lot of structures here. And this is a georeference database, so you can also visualize this in QGIS, and we will see that later on. So I'm just going to put it down, because what we will do right now is to prepare the exposure file for OpenQuake. Okay, so what we're going to do is we're going to prepare. I'm going back to my desktop. We're going to prepare the files for OpenQuake for the calculation, and the first one will be the exposure. So what are we going to do? We're going to double click on this white and blue icon, okay, to start the OpenQuake engine. For the person that is using the Mac OS, you do not have the icons installed, because in Mac you don't see the icons being added in your desktop. But from your console, you can start the web UI or the web user interface with the following command that Kata will share there in the chat. I believe it's OQ web UI start. And then that will bring you, just double click here, and you will see that 2 things are occurring. First, you will see that there's a small there's a small black window. Basically, the engine is starting on the background. But once it is initialized, you will see that it appears for you in this way. You will see that it appears for you in the OpenQuake engine tab. So why is it called web UI? It's because it's a user interface that uses a web browser. Now, the typical question here is, so you mean that I need internet in order to be able to use OpenQuake? You do not need internet. The only thing that you need is a web browser. So you can see right here that I am not connected into the internet. I'm actually connected to my local machine. So if I have Firefox, it will bring the OpenQuake engine in the Firefox browser. If I have Microsoft Edge, if I have a Google Chrome, we will see those windows opening, but we do not need an internet connection to be able to do what we're going to do today. So those are good news. I also see a message version about the version that I have. For example, I'm still using version 3.11 right now. So all of this is good, 11.4. I think you are also using a version 3.11.4. Don't worry about not having the latest version. Actually, 3.11 is the one that we need today, so that's good. And it's the one that you have installed, you should have installed. What you're seeing here is my previous calculations. So I'm an OpenQuake user, so I have some calculations here from earthquake scenarios and things like this that maybe I was modeling in the past. That's fine. So this is the OpenQuake engine interface, web user interface. So the interface is quite simple. You see the calculations here and you have two buttons, one button to run a calculation and one button to use the tools. The tools are important and we're going to right click on the tools and open them as a new web window. The reason to do that is because we always want to have the engine and the ability to run a calculation in one browser tab and the tools on another browser tab. So again, I'm going to go back. We're just going to right click and open the tools as another window in the tab in the browser. So right here, what we are going to do is we're going to prepare the files for the exposure files. So when we're building the exposure and we're exposure modelers, we need an exposure that looks like this, right? We have these columns and we have in every row the assets, okay? OpenQuake needs to read this. So what we're going to do is provide OpenQuake with these two, information. So today what we're going to use, we need to be located in the first tab of the IPT. The IPT is this set of tools that we use to build files for OpenQuake. So it's called Input Preparation Toolkit or IPT, and we need to be on the first tab, the one that is called Exposure. So in the tab of Exposure, we're going to write Exposure Model for El Ruiz. Description is basically the main description of the file that you're preparing, so you can later on see it and remember what it was. You can be as descriptive as you want in the descriptions. The more concise, the better. The more descriptive, the better. Structural costs. Today we have aggregated structural costs. What does that mean? We have aggregated structural costs and we have them in US dollars. So what does that mean? And you can put here, remember to be in aggregated and US dollars. And what that means is that the value that is reported in the structural column, in the economic value of the structure, is the aggregated value of all the buildings here. So if I have 4 buildings here, then the value reported here is the value of all those 4 buildings. That's what we mean by aggregated. You can also here, as you can see here, you can also have the values per building or per area reported in this column, but today we have them aggregated. That's what it means. What else do we have in that exposure model? Do we have retrofitting costs? No, this is something a little bit advanced. Do we have limits or deductibles? No, we're not doing insurance analysis here. Do we have non-structural or contents costs? We do not have. We also don't have business interruption costs. Today, we simply have structural costs. Do we have occupants in this file? Yes, we do. We have occupants in this particular column called night, or which is the occupation attribute. So we do have occupants, and we're going to say the occupants, we are using a night model of occupancy. Perfect. And you can see that as I add things here, the number of columns that should be in my exposure model keep appearing here. So I'm going to do ID, long lat, taxonomy number, structural and night. Let's see, I have ID, long lat, taxonomy number, structural and night. Perfect. So I have the main things that I need to do rest, but the earthquake modeler, or the exposure modeler gave us additional information. In this case, earthquake taxonomy, census ID, department, and municipality of each one of these assets. So let's add them as additional tags. And the key here is that the tags need to be exactly in accordance with the exposure file. So the first one is EQ_taxo, okay? Is this one right here, EQ_taxo. The second one is ID_censo, okay? And then I add it with the tab or with an enter. The third one is DPTO or department, DPTO, which stands for department. This is a small word for department, and MPIO, which is municipality. Okay, so you can see that by adding those here, I have the IPT tells me you need these columns in your exposure if you want to include all of that, and I can see that all those columns are here. So we're perfect. The only thing that we need is to provide that CSV file that contains all this information. So what we're going to do is click on upload. We're going to upload, click on upload, and we are going to go to today's material. Mine is in the desktop, example and Ruiz. I'm going to do this a little bit bigger. Just give me 1 second for you to see. So mine is in the desktop, in example and Ruiz, in the folder called exposure. I see 2 CSV files, the exposure for the rural areas and the exposure for the urban areas. The exposure modeler created 2 separate files, and we can specify to OpenQuake that we have 2 separate files. So by clicking on control, what I click on control, what I select the 2, I want this one and I want this one too. And you can see that both of them were added. Click on one with control pressed, and while control is still pressed, you click on the other one and you will be able to open or add those 2. And you can see that both of them have been successfully uploaded, but they have not been selected. So I am going to select, click on one until it becomes blue, with control still pressed, click on the other one. So both become blue, both are selected. And then I can convert this to the NRML language, which is the language that OpenQuake uses to read input files. So I click on convert to NRML, and I can see that basically OpenQuake is using everything I put here to generate this XML file. This is how the NRML language looks like. This file is ready for us to download. So if you click on the download icon, you just click on download right there, and it's going to download your exposure zip model. So this file contains the data just as OpenQuake needs it. Very good. So we just went through the process of preparing the exposure file for the calculation. Does anyone have a problem up to here? Didn't find the exposure, found an error here, couldn't select both files, anything in particular?
We also share on the chat the input preparation tool. This one that we are using is also available online. So for the ones that didn't install the engine, at least you can prepare the files here if you want to follow the example. But it would be good if you give a thumbs up if you manage to prepare the files, so Alejandro knows if it's going a good pace or not.
Okay, yes. Also feel free to raise the hand and let me know if you found the issues. Today we're having it's kind of a 30 people, so we can still discuss among us. If you have any questions or problems, just let us know. So perfect, we just did the exposure. So we are ready for, we have the exposure file ready for us. That's very good. Let's go to, I am going back to the presentation, okay? So we already explored the exposure model. What we're going to do now is we will estimate risk for each one of the perils, okay? So we're going to estimate the risk level basically of damage and loss created by the lava flow, by the PDCs, by the lahar risk, and also by the ashfall, okay? So this is what we're going to do now. How do we do this? We need first to prepare the input calculation file. So we're going to go back to the input preparation toolkit. Okay, so we will come back to the input preparation toolkit. And we're going to move from the tab that says exposure. I am going to move all the way to the tab that says configuration file. So I'm going to click here on the configuration file. And what I will do is, in the configuration file, you can see that the IPT allows you to create a configuration file for earthquake scenarios, for classical risk, for stochastic event-based risk. All of these is earthquakes. What we need is volcano scenarios. Okay, so we're going to click on volcano scenarios. So a configuration file is basically the file that tells OpenQuake what I want to do. Okay, so it will tell OpenQuake what kind of calculation do I want today. So the calculation that we're going to do today is a volcanic scenario. So I'm going to click on the tab volcanic scenarios. And what I'm going to do is provide a description, okay, for the scenario of today. So we're going to say that this is a volcano scenario calculation, and we're going to say el Ruiz and all perils, okay? Because in a single calculation, we're going to specify the 4 perils, okay? It's not just ashfall, it's not just lahars. Today, we want to estimate risk for all of them, and we will be able to visualize risk for all of them. So because I want all perils, here in the tab of perils, I'm going to select all of them. So I have ashfall selected, I'm going to select lava flow, I'm going to select lahar, and I'm going to select PDCs, okay? So perfect. Let me see if I need to see if there are questions in the chat. No, everything's fine. So for ashfall, as Tato was telling us, we can have an output file from Ash 3D. So if I have an input file from Ash 3D, I can upload it here, and that would be the ashfall hazard footprint. Okay. Today, what we have for ashfall is a CSV a file. So later on, you can explore it by yourselves. But the file that we will upload today is actually a CSV file that has discrete points with the ashfall intensities. As Kata was saying, longitude, latitude, and intensity of the ashfall fall. Okay. So we are going to upload the hazard footprint. How do we upload the hazard footprint? We are going to click on upload. And we are going to go again to today's example. Mine is in my desktop, example El Ruiz. And we are going to go, we were in exposure, we have fragility, we're going to go into hazard. Okay, we're going to double click into hazard. We're going to double click into ash. And let's take the first one, scenario 1 with the maximum values. And we're going to select ash load Nevado más 100 meters. Okay. This is basically 50, 100, and 500 is basically the discretization of the grid that has the longitude, the latitude, and the intensity. So let's select 100. 100 is basically a file that has every 100 meters in a grid. It has a longitude, a latitude, and an intensity. Later on, you can explore how do the other CSVs that we're providing look like, etc. So perfect. So we set a default CSV format. We just provided the ash load for Nevado. I am sure that it is selected because it appears in blue right here. So perfect. And we are going to provide the acid hazard distance. What is acid hazard distance? And this is the first, actually, this is the first input parameter that it's not easy to understand. What does this mean? So you can always hover over this small question mark item to understand more or less what any of the input parameters mean. So it says here that the acid hazard distance in kilometers is the parameter that indicates the maximum allowable distance between an asset and a hazard, a point with a hazard intensity, okay? So basically, the distance that I want to consider, okay, so I'm saying that I have ashfall in this particular site. If there are structures within this particular radius, apply that intensity within that radius. And let's say if it's kilometers, let's say 0.1. So if I have a point, let's apply that ashfall for structures around that point that are within 100 meters of that point. And I think that's an acceptable radius to apply. Do we have ash wear amplification factors? Again, you can hover and is the factor to amplify the density of the ashfall. So if it's wet, we need to amplify that. and we need to provide a factor. Very good. I guess this will be an analog to what in earthquakes is the amplification of the seismic wave or the seismic intensity due to the local soils. In this case, due to the humidity or wetness of the environment. So far so good. Everything's good. If anyone has a question or if I'm going too fast, please let me know. Raise your hand. I am happy to go a little bit slower. No problem whatsoever. So we also have for the lava flow, we're going to select which input format do we have. For the lava flow, these are binary files now. So for the lava flow, we are going to provide, for the lava flow, the lahar, and the PDCs, we are going to provide actually shape files. Okay, so shapes that contain the hazard footprints. So it's a shape file S3 vector, and I'm going to upload it. In my computer, I have to click twice on the upload button, so make sure that you click. If the window doesn't appear, click again. And I am going to go again to desktop, today's exercise, hazard, and we are saying that this is lava, right? So for lava, I go into the lava, sorry. I'm going to select the lava shapefile because it's a shapefile. It's a shapefile that we're providing. Is this zip right here? So double click on it. And we can see that for the input format, we set a vector and we just provided the shape.zip file, okay? Has to be the zip file. For the lahar, we're going to do the same. We're going to go shapefile, upload. I click twice, very good, it appears. And I am going to select the lahar shapefile.zip. Perfect. I make sure that it's highlighted in blue. Yes, to make sure that it is selected. Pyroclastic density currents. I am going to, we are going to be using also today a shapefile. It's also a binary hazard. So I am going to select a shapefile. I'm going to double click, upload. Perfect. And I am going to select the shapefile for the PDCs. Okay, so perfect. I just defined, I know that the ash is a different intensities, a point file that has long lag intensities, and the others are binary input files or shape files. Exposure model. So the IPT is asking us, do you have an exposure model? The answer is yes. So we can upload an exposure model, which is the file that we just prepared. Okay, so what we're going to do is we're going to go to downloads. And is this file right here, is the one that is called exposure model that we just prepared. So it is uploaded successfully, not selected. You can see that it's not selected in my case. I'm just going to make sure that it's highlighted in blue. Perfect. Do we have a taxonomy mapping today? No, we don't. This is an advanced feature. We won't discuss it today. But we do have a fragility model, okay? So we provided you with a fragility model that you can explore later on. I will just let you know where it is so we can upload it here. Just click on upload, and we're going to go to today's exercise, example Ruiz, and in the fragility folder, we are going to select Torres Corredor et al, okay? And you can see that there are other models there that you can also explore, but today we need to use Torres Corredor et al. Make sure it is selected, not necessarily, it has to be in blue, the name of the file. And do we have a consequence model? So we're providing a fragility file, which means we can estimate damage from ashfall, thanks to the ashfall fragility curves from Torres Corredor et al. But to estimate losses, how much does it take to repair that damage? We're going to need also to upload a consequence model. So click on upload, and in the same folder, there is a consequence model that we're providing. You can also explore later on how that consequence model looks like. So we're ready. We're actually ready to run the calculation. So let's just make sure that we have everything we need. We have a description for today's exercise. We have the 4 periods selected. Ash, it's in a CSV file that we selected, acid hazard distance every 100 meters and 1.65 for the wet amplification factor. The rest are binary files, so they are shape files. Perfect. And we have Torres corridor fragility, and we have a consequence model. Perfect. So make sure that all of them are selected, that none of the drop-down menus are blank. Make sure that everything is selected. Seems like in my case, everything is. I just need to download the zip file. Okay, so I'm going to click. And this zip file that you can see here, Volcano zip, that zip file is what I need to run the calculation. Everything is done. We provided OpenQuake, the IPT, we said this is the exposure, this is the hazard footprints that I have, and these are the other parameters that are important. The asset to hazard distance, the wet factor, in other words, everything has been absolutely defined or completely defined. So we are ready to run the calculation. Let's do it, and then we see if anyone has any issues running the calculation, okay? So how do we run a calculation? We said that we need to have the two tabs open, the one with the run calculation button and the other one with the tools. Let's go back to the one that says that has the button to run a calculation. You click on that button, run a calculation, and then you have to select the zip file that we just downloaded, the one that says Volcano zip. So we go to downloads, we double click on Volcano zip, and there we go. OpenQuake, when it's executing a calculation, it will show you everything, the calculation in a yellow. Once the calculation is done, it will appear either in red or in green. Red means the calculation failed, either because Alejandro, in hazard to hazard distance, he was supposed to provide a number and maybe he provided a letter A, B, C, and that would give you an error. Or these kind of errors, but definition of any parameter, you will get an error there. If the calculation is successful and everything runs successfully, you will see that the calculation turns on green and it would say complete, just like these ones right here. So does anyone had any issue preparing the zip file? Is anyone not being able to see this calculation executing right now? You can raise your hand and we can know if you had any issues. This calculation takes more or less 2 to 4 minutes executing. So for you to get an idea of how much a single calculation, no uncertainties, as Kata was saying, we only have one hazard footprint for ash, one hazard footprint for lahar, etc. This takes 4 minutes. Eventually, when you include uncertainties, they can take more time, but obviously your risk assessment will be more robust. So this is something to keep in mind. I don't see anyone with any issues in the chat either, but please interrupt me if I am missing questions or anything in the chat. Francisco, there's a technical issue. I can go through the documentation later on. But in my Linux, the interface says run a calculation, but it doesn't, the tool, yeah, as Linux users, you don't have the tools tab, but you have the tab that that Kata just provided is the tab that you can use online to prepare everything. If you did not manage to prepare everything with me because you didn't see the tools and then now you're behind, just to give you, we are prepared for that too. So later on, you can explore how to do it or review this video. But look, you can still run the calculation by doing this. Run a calculation, you click on run a calculation. And in today's exercise, material, mine is in the desktop, example El Ruiz. In references, you have one zip that is called El Ruiz All Perils. Is the zip already prepared? So just double click on that and you will be running the calculation, even if you were not able to follow everything. And you can see that we also provide zip files for each individual peril too, if in the future you want to explore the results individually for each. So perfect. So very good. So very good. The calculation should be running. If everything goes well, it will become green, and that is perfect. Up to this point, we have been using the engine and the IPT. Once the calculation finishes, you will be able to access all the results, and the results you can visualize as everything in risk. The results, the most important results, are actually geographical data, is geographical information. Today, we're going to show you how to visualize it in QGIS with a specific tool that we have, okay? If you want to see them in ArcGIS, if you want to use any other tool that you want to use, that's fine. You have full freedom to use any other tool that you want to visualize the risk results, okay? Today, we will be using a particular plugin that we developed for the QGIS platform, and that's why we asked you to install QGIS. What we need to do right now is, first of all, you can see that my calculation became green. So let's just explore that. If you click on the button that says console, this is going to open a window that tells you how the calculation went, okay? So it tells you, okay, you tell me to run this calculation. You are using this version of the engine. This is your computer capacity, etc., etc. It tells you, this is how many sites you have in your exposure model. This is how many buildings you have in your exposure model. It tells you several things that are of importance. For example, if your calculation failed, it will appear in the console the error message. So the error message may be you did an error specifying the asset to hazard distance, for example. Or if the error is cryptic and OpenQuake says I failed because of a strange message, you can always go to the OpenQuake forums and explore if this message has, what does this message mean? How can I solve this issue? All of that is in the OpenQuake forums of users. And this is actually the way the community of OpenQuake interacts to troubleshoot their own issues and things like this. Just to let you know that the manual doesn't have everything. It's very good and very nice to interact with the community. There's always a lot of people willing to help. And there is always the GEM Foundation members to help also with this kind of problems. So far for me, no need for that. Everything is in green. So console says everything is fine. My calculation took 200 seconds to run. Very good. You can let us know in the chat how long your calculation took to run. Maybe you're still running. Maybe it will take 10 minutes. Maybe you have a better computer than mine and it's running 1 minute. Let's just check. Very good. I can see that more or less the median, the average is over 200. Very good. If I click on outputs, for example, what am I going to see? In outputs, I see all the outputs of this calculation. It means that the calculation, you already have all the results. What we're going to see when we graph the results, plot the results and all of that, that's just the plugin that we're going to use. And it's just, we're using QGIS. But what I want to emphasize here is that you have all the results for you to plot in Excel, to plot in any tool that you want to visualize. For example, the exposure with risk is a CSV file that you can download and visualize right now. The total risk is a table in CSV that you can download and visualize right now, and visualize it as a matrix. So again, the calculation, once it's successful, all the results are in your computer. And what we're going to see now is just how to visualize them given a tool that we're providing. So let's go, how do we visualize them, the calculations? What we have to do is we're going to go, I'm going to minimize everything. I'm going to go to today's exercise. In the folder, there is a small, there is a file. After all the folders is this file. Let me make this a little bit bigger. Is this file, the QGIS file is called gismaps.qgset. Double click on that, and that is going to start the OpenQuake, the QGIS project. So what is the QGIS project? Let's give it a while when it opens. Okay, mine is already open. The QGIS project is a set of layers that we have put today together for you, so you can visualize where is the Ruiz Volcano, and you can see it here. I'm not stopping to explain more or less how QGIS works, because I think a lot of people here is very familiar with GIS software. But basically, we have a set of layers that contain the geographical information that we want to visualize or that we need to understand today's scenario. In QGIS, to turn on or off the layer, we use this little checkbox. So right now we can see that the Ruiz Volcano is right there. And we even provided the Google satellite imagery if you want to visualize a little bit. I'm zooming in the volcano so you can see that indeed we are in a region where we're having the Ruiz Volcano right here. Perfect. So we know that this is the potential damage phenomena. We know that this is the source of the hazard. Perfect. Let's visualize the hazard footprints. Okay, so we can see that we have lava flow, we have pyroclastic density currents, and we have lahars. Okay, so those are the three. I'm sorry, and we also have the ashes. I'm going to turn off this so we can see the ashes well. And with this little arrow left to the layer, if you click on the little arrow, you will see the different intensities of the asphalt that we are using today. So in different the different intensities, and if you zoom in, you will see that is indeed a set of longitude, latitude points that each one contains the intensity of the asphalt. The rest of the things that you see are just geographical information. Yes, we will share the video with you. Someone is telling us that, asking us if we will share the information with you. Yes, we will. We will share the information with you. The video eventually. Usually our videos, we upload them in YouTube. But we have your email, so we will also let you know when the video has been uploaded. Very good. So I am just, okay, so we explored that we have this, and we also told you that we have the volcano, we have the hazards, right? But we also told you that we have exposure. So we have exposure, actually, we have exposure for the entire area. So we have rural and we have urban exposure. Those are the two exposure files that we just generated. Here we can see that in one we have the high density areas or more populated areas, and with a 3 we have classified the areas that are more rural, and the rest of the geographical information is important things to understand, which are municipalities and departments of Colombia. So far this is the project. Okay, what we're going to do now is install the plugin that we need to use we're going to install the plugin that we need to use to visualize the results in OpenQuake. Okay, so what we're going to do is we're going to go to the plugins tab of QGIS. Okay, and we're going to manage and install plugins. Okay, so we're going to click manage and install plugins, and this is going to bring up this particular tab. Okay, so what we're going to do is we are going to look for the plugin to install. The plugin to install is called OpenQuake Integrated Risk Modeling Toolkit. So if I'm in the tab that says all, I will write OpenQuake. Sorry, OpenQuake, and you will see that there is this particular plugin that you need for today. You click on the plugin and then you install the plugin. You click on the button that says install the plugin for you. I'm going to repeat the process. In the plugins button, you need this one in order to be able to visualize the results. So in the plugins button, we click on manage and install plugins. In all, okay, so you're going to click in all plugins. You're going to write OpenQuake, and you can see that the options collapse in the OpenQuake Integrated Risk Modeling Toolkit, and you're going to install the toolkit. Okay, and this is going to install the stable version of the plugin, which is the 3.11.4, which is the same as my OpenQuake version, and that is very important. The plugin has to have the same version of the OpenQuake engine in order for them to communicate properly. If you have a plugin that does not correspond to the same OpenQuake version, you might experience issues. Okay, so just for you to keep in mind. Let me know once the plugin has been installed. Just you can give me a thumbs up. You can let us know if you managed to install the plugin. Perfect. Okay, so I can see Catalina is helping some people in the chat. That's perfect. Just let me know if everything's fine. If you have any questions so far, just let me know. So what I will do now is show you how to use the plugin. So once the plugin has been installed, you will see that these new icons appeared on your QGIS project. Okay, so in QGIS, You should use, someone is asking, I already installed the plugin. That's very good. If you install it the way I said, you already have the plugin that is necessary, that is compatible with the version of OpenQuake that you installed. So that's fine. It's the 3.11.4, the one you can check your OpenQuake installation in the web UE, in the web browser. And that's the one that should be installed right here using the plugins. So that's the one that should appear right here. So for those of you who managed to install the plugin, new icons on your project will appear. It's the blue and white icons, okay? So in the blue and white icons, we will be using this one that has the blue arrow, the play icon, okay? So that's the way we bring up the plugin that allows us to bring these results into our QGIS project, okay? So I'm going back to QGIS. To visualize the plugin, I'm going to click on this button. I click there, and this is going to bring the plugin. Okay, so this is the plugin of OpenQuake for QGIS, and it's not a coincidence that it's actually the same as this interface. Okay, so it's actually a mirror of your web user interface. Okay. That's the plugin is actually a mirror of your web user interface. In the plugin, you have a button to run a calculation. You can even run a calculation from the plugin here. And you see also the calculations that you have executed so far. Super important. If you want to use the plugin, you need to have OpenQuake running in the background. If OpenQuake is not running in the background, the plugin won't work. Because the plugin is just a tool that brings results from OpenQuake. If OpenQuake is not available, the plugin is going to fail. It will try to bring results, but it's not going to find them. So for the plugin to work, you need to have this also open in your web browser, okay? So OQ Web UE Start for Mac users, or double click on the blue and white icon of OpenQuake when you're going to use the plugin always, okay? So you need to have started OpenQuake and running OpenQuake in the background for the plugin to work. So let's go back to the plugin. Again, how do I bring the plugin? I just click on this button right here. QGIS plugin is this button right here. It brings it right back up. And I can select which calculation I want to bring results from. In this case, is the volcanic scenario calculation, el Ruiz with all periods, okay? So how do I know that I'm bringing results from that calculation? Is the one that is highlighted in blue, okay? So once it is highlighted in blue, or if it is not, just click on it once and it will highlight in blue. Once it is highlighted in blue, I can see the results that I can bring to QGIS. So we see that we have exposure plus risk, we have a full report, we have the input files, and we also have the total risk. Turns out that the outputs that have geographical information is this one, the exposure with risk. We can visualize the risk geographically, but we can also, let's first explore the total risk in terms of a table. Let's see a table of results. So you click on load a table, and this is going to bring you the table of results for the periods that you selected. So for the periods that we have today, ash, dry and wet, lahar, lava, and pyro, we have a set of results. Number and occupants mean how many buildings are exposed to that layer, to that hazard footprint. That's why for ash dry and ash wet, we do not have any numbers, because that layer is not a vector. It's actually a long lat point file, okay? So those, we cannot count how many buildings are inside that layer, that grid. But for the ones that are shape files, we are, the plugin right here is giving you the results of how many buildings and how many occupants at night are for each one of those hazard footprints. So inside of the lahar footprint, 7,000 buildings and 15,000 people. For lava, 1 and 4 people, and for PDCs, 208 and over 1,000 people. So 200 buildings over 1,000 people. And for each one of these ones, we also have the loss structural, so the loss, economic loss of the structure, And here is the aggregated value. So the losses collected from these 7,000 buildings, all the losses collected from this building, and all the losses collected for these 200 buildings. Remember that the losses are, in this case, US dollars. And we also have the buildings that fall into different damage states. For ash, dry and wet, we can see that we have the number of buildings that fell in no damage at all. They were not affected by the ash. And we have how many buildings were affected or collapsed completely, let's call it damaged completely, because of the ash fall, okay? So for dry, we have obviously more buildings than for wet, because the dry intensity is lesser than the amplified wet intensity. The question is, why don't we have this for lahars, lavas, and pyroclastics? The answer is because remember that we associate fragility to damage, and we only have, in this case, fragility models for ashfall. In the other cases, there is no fragility models, so there is no differentiation in the level of damage. Basically, we're saying that what was inside the hazard footprint was completely damaged. So this is why it's also important to report here how many assets and people were inside that hazard footprint, okay? So this output, total risk, the output of total risk is the aggregated risk results, okay? Is the aggregated results for the entire phenomenon, okay? But we can also visualize the results per single asset, and we can also bring the results of every asset and make maps that show us the losses. So for example, C Lama is asking me, is it possible to get the standard deviation of the losses? The issue here is that these are deterministic hazard footprints. We do not have many scenarios of footprints. So we cannot calculate the standard deviation because we only have one result. You see? So this is one of the limitations where that we have today, that we want to address today. And this is one of the things that we can improve upon in the future. And that is actually what we want to transmit today. If we were modeling earthquakes, in OpenQuake, we will be able to right now obtain damage statistics, you know, so you can have the mean, you can understand what was the minimum and the maximum of all of these simulations that we did. But right now, since we only have one hazard footprint for each one of the perils, we only have one result. We cannot compute the standard deviation of the losses today. I hope I was able to answer Lauma. I don't know if Tato wanted to add something there as well. Okay, perfect. So let's, we already saw the aggregated value of the losses. Let's check and let's do some damage maps and some loss maps, okay? So how do we do that? We are going to use, I'm going to click, make sure that my calculation is in blue. And I am going to load a layer, okay? Exposure and risk. I'm going to bring a layer, and I am right now going to create a risk map, okay? So I am going to create a risk map, and I am going to select the lahars, okay? So I'm going to create a risk map for lahars. And what I want to plot is I can plot the economic loss, the number of buildings lost, or the number of occupants affected by these lahars. Let's plot the economic losses, okay, that are due to this lahar, and let's create this map. We can also select the zonal layer, or basically how we want to aggregate. You want to see the points? You want to see the risk aggregated by departments or municipalities? Let's choose municipalities, and let's click on OK. And we are going to see basically that all the information is being brought. You can see right here below. This takes time. We have 400,000 points. So basically what we're doing here is aggregating the points per municipality, the risk per municipality, and we're going to report it as a risk map. So this risk map, because we selected structural losses, what this map represents is the economic risk. Now, this is what we have time to do today. Later on, by yourselves, you can explore by yourselves the outputs. You can generate different maps and you can do different things. So I'm just going to go back here so you can see that the plugin already brought the risk 0.5, so basically the losses for every point in the calculation, and it's already generating for me the map of economic losses. So let's just give it one moment. It is about to finish, but you can see right here that this is the actual resolution of the exposure model. So you can see that in the dense zones, we have certain buildings actually located using a particular grid, and in the rural areas, we have a different grid, maybe because we use a different data set to generate those assets right there. And we are about to see the economic loss maps. So we're coming close to an end of the workshop. So this is all that I can show you today. You already know how to, most of you know how to use QGIS. Most of you know how to generate maps using QGIS. I'm just going to show you that I can ask, for example, for the losses be classified into using different colors or different categories. And what I am seeing here is the economic loss maps given the lahars. So you can see, for example, if I select the lahar right there, we can see how the lahar affected the exposed area. So I am going to finish right here. I leave it up to you to explore damage maps, different things, explore the outputs, look at the CSV files, download them in your computer, try to plot different things, not just using QGIS, but other things as well, other options that you have available. And please let us know if something wasn't clear, or if you have any questions or anything. I'm happy to answer. I am giving back the word back to you, Tata, so you can let us know.
Thank you very much, Alejandro. For everyone, because perhaps you have a meeting right now, I see that many have been disconnecting. I just shared a link to a survey in which you can leave your feedback and your suggestions. How was your experience during the workshop? Next week, we will share the recordings. We will try to fix a bit the mess, because at the beginning, the initial part was not recorded in my computer because it crashed, but we will try to share it. This is an ongoing project, long-term project for OpenQuake, which means bring risk impact for volcanoes and perhaps other perils. So any comment, suggestion will be very welcome. Alejandro here is showing us the risk impact for lahars, but you can visualize it for any other peril that we model. Also, for instance, in a risk, some stakeholders ask us, can you generate debris risk? And if we treat debris as a binary peril, then we can also use it, even though we'll have another name, but kind of we can trick the engine to have other type of binary perils. So I think that's all for today. We again thank you all. I think it's quite exciting to have other audience and other expertise that could bring additional features, feedback for the OpenQuake engine. Also, it's nice that you can be aware about models that we do for earthquakes that perhaps are also useful for you in your work on volcanoes.